Django Unchained is a great movie that takes place during the pre-Civil War South, showcasing a great revenge story as Django, a former slave, becomes a bounty hunter as Dr. King Schultz needs his help. This is one of the 8 movies Quentin Tarantino has written and directed and is one of my favorite movies of all time, but one thing has always stuck out to me.
Cole, before you go, will you tell Miss Laura goodbye?
Do what now?
I said tell Miss Laura goodbye.
Bye, Miss Laura.
In this clip, Django shoots Miss Laura, and she flies back way too far, way too fast.
So let's find out how fast Miss Laura is moving. So first we need to find how fast the bullet moves, and then the momentum of that bullet, and then using her mass, find out how fast she should be moving. Looking at the pistol Django uses to shoot Miss Laura, it is a Remington 1858 New Army pistol, and the internet gave a few different bullet speeds, but averaged the bullets travels around 635 feet per second, and converted to meters per second, that would be 193 meters per second. The average mass of the bullet would be about 15 grams, and using the equation momentum is equal to mass times velocity, we can get the momentum to be 2.9 kilogram meters per second. After the bullet leaves the gun and hits Miss Laura, the momentum will all be pushing into Miss Laura, and by the law of conservation, she will be experiencing 2.9 kilogram meters per second momentum. The actor is about 5'10" and is a little on the lighter side, so I guess she's about 120 pounds or about 55 kilograms. So using the momentum equation again, we find she should be moving about 0.052 meters per second. Analyzing the scene very carefully, I've taken that in about half a second she traveled about twice her height. So doing a quick velocity calculation being distance over time, that means she was actually traveling at 7.12 meters per second. This is extremely fast and way more than what she should be moving at. All of this not taking into account how even though Django shoots from a weird angle, she flies straight back. To help visualize this even more, we can take her weight being 55 kilograms and her actual speed being 0.052 meters per second, and using the kinetic energy equation, kinetic energy is equal to 0.5 times the mass times velocity squared, we can see that she should have about 0.07 joules of energy, whereas using the movie's velocity, she's about 1,394 joules. For her to travel this fast, she would need to be either been hit by a faster bullet or a bigger bullet. Now, reversing the math we did earlier, we can find that she needs to experience about 391.6 kilogram meters per second of momentum, which will make the bullet, if at the same speed, need to have a mass of 2.02 kilograms. This may not seem like much, but a tank shell is about 4 kilograms, and the biggest rifle that shoots a non-explosive, a .950 JDJ, has a mass of 0.23 kilograms and could easily punch a hole through someone and not send them flying. This scene does not adhere to normal physics.
Django, have you all